looking at question 16 here, we want to predict our products, and we're starting out with a ester, and we're going to react that ester with an amine, and in that reaction we always end up with an amide and an alcohol. Now overall, the mechanism or the actual products and reactants, we don't necessarily see exactly why this 2 is made, because in that overall mechanism, the only thing we're going to do is right there where that O was on the carbonyl, we're going to attach this in instead, lose one of these H's, and leave that CH3 there. And then this part that came off of the ester, the O, CH2, CH3, gets the H that came off that amine. All right, so that doesn't actually show why we need this. All right, but then to see what's going on, I was going to go ahead and do the mechanism, and that will show us where that second NH2 or that second amine comes in. All right, so to see this whole thing in nice and big pictures, we're going to do the mechanism. I'm going to go straight down, but the very first thing that's going to happen is I'm going to have that lone pair on that nitrogen do a backside attack to our carbonyl, giving us, I'll try to leave this skeletal as much as possible, but this carbonyl is going to become a single bond because when that attack happened, these things moved up here and created a negative ion. So on this other side, we still have this thing, and it's going to be fully intact. So I'm going to actually have both H's here, but I'm going to draw them out a little bit, and then just have that CH3. And then over here I have the O, and then I still have the 2 carbons. I'm going to label those. Can't really do that zigzag too well. Okay, all right, since this went on intact with no changes as a neutral molecule, it's now going to have that nitrogen be slightly positive because that lone pair became the bond, making that a quaternary nitrogen. All right, now on many of our mechanisms, our next step was to have those lone pairs on that O negative come back in, and then we'd end up kicking off the OR. We're not going to see that this time. Since we put on a neutral molecule, we're going to have something come in and neutralize it. Now in the past, some of these, we just had base. Basically anything with a lone pair will do it. In this case, the reason I had that 2 there is to remind us that if you were to do this, you're going to have to put in extra amine, because the amine itself will act like the base, and it's going to deprotonate and neutralize that molecule. Now, when that happens, we're going to finally end up with that neutral species that we're looking for, with just that 1 negative. Charge is gone. And then we have a step that looks kind of similar to almost all these other mechanisms. That's going to come back, reform the double bond. This is going to get kicked off. I'll just put the NH here. And that is going to look like at first OCC with a negative. But back over here, this guy, that CH3NH2, had, after it took away the proton on that step, had turned into CH3NH3 positive. And these guys kind of react, giving us our alcohol, and we've lost that H. We're just back to how this was to begin with, which is why it doesn't appear in that upper mechanism that we needed.